Sharifa Sahai. Um, I'm a second year PhD student in the Systems, Synthetic, and Quantitative Biology program at Harvard. It's split between the Harvard Med School and the Harvard University main campus. I work in the lab of Faisal Mahmood at the Brigham Women's Hospital. We develop computational pathology algorithms for diagnosis, prognosis, and prediction related to cancer and other medical problems.
Yeah, all right. Nice to meet you, Sharifa. So just getting into our questions for this interview. First one, starting off, how did you first get involved with research in computer science and biology?
Interesting. I started college kind of being pre-med, but computer science. And, um, I was doing a biology major and a computer science major. And my professors kept telling me, this is a really good area, this intersection. And, their professors said, like, oh, you should try out research, maybe, look into that. Bioinformatics, computational biology is coming up. So I actually, I started, and I wanted to apply to research positions, but you need experience to get internships. So I did a bit of research in an undergrad lab a few hours a week on Drosophila genomics. That was mostly just designing primers and, just a very limited amount of bioinformatics work. Some wet lab in terms of I would, knock out the flies and mush them up so that they could, be sequenced. Um, but yeah, after that, that kind of led me to have like a little bit of research experience on my resume, and I was able to apply to positions. So my first summer I was rejected from some places, but my second summer I got an internship at the NASA Jet Propulsion Lab in California, and there I worked in the planetary protection group doing research on, creating a database of microbial cultures for them. So they swab spacecraft before they go up, and they make sure that and they categorize the microbes in the clean room, so that if when we go to other worlds, and we discover life, it's not our own life that was introduced there from space, from space debris that we had landed there. So that's the research they do, and making sure to protect other planets. So that's what I really did was they really needed my ability to understand biology terms, and be able to implement what they wanted, like in assays and data input methods in a database. So I think I didn't have like deep expertise in either the microbiology or the computer science at that moment, but my ability to have a foot in each really allowed me to do well in that project. And I was very surprised when I got the offer for the position because I was only a sophomore at the time. But not many people at that time and still now are in this intersection of computer science and biology. So that was how I started, and then I continued doing research. In my next summer, I applied to do the Stanford summer research program. So I did research in a wet lab on prion yeast genomics. So and that was a bit tougher. It was a wet lab, 8 hours a day, pipetting. Not It definitely makes you appreciate data a lot and the intensity of wet lab, but I realized I preferred computational methods and that work. So that's where I've steered into now in my PhD work.
Yeah, that sounds great. It's super interesting to hear about the roles you've had, and even as you were saying, when you didn't necessarily think that perhaps you had like the deep knowledge that you needed. But that's great to hear. So yeah, kind of transitioning more into your current work, it sounds like really interesting how you're using these deep learning methods to analyze medical images and inform diagnoses and stuff. Could you talk a little bit about kind of just what these methods look like and how they actually analyze these images?
Okay. Well, it's based on computer vision, um, deep neural nets. So I mean, if you think about it from, well, this is also, it's like what way to frame this. I could talk a bit about what's normally done in computational pathology, where you take an image and you have pathologists look at like each patch. You divide the image up into many patches. So these images can be over a gigapixel in size. So they'll take the patches and like say like, oh, this is inflamed, this is not inflamed. Like they'll annotate which regions are of interest, and then they'll use that sort of hyper labeled image in the neural net. But my lab does is we use a deep learning weakly supervised approach where we use a slide level label. So instead of annotating exactly what region is inflamed, we attach a label like this slide has inflamed tissue. This slide has this kind of diagnosis. Instead of manually annotating that image of what areas are inflamed, and we use that. So first, it would the image is odd. The tissue from the image is automatically segmented, and so as I said before, these images are huge. So patches of 256 by 256 are automatically extracted. Those patches are then put through a CNN feature encoder, which extracts the relevant feature representations. That is then put into our sorry, our multiple instance learning module, where we will take the representations of the I'm sorry the where we will take these patches and basically rank them in their order of importance of how we got their score. So higher level patches patches that correspond highly to a diagnosis, to the slide level diagnosis, will be ranked higher than the other patches. So this is like an intention pooling mechanism. These ranking parameters are then used in the final layer for the classification problems. So, and then that is when you will classify, you could do tumor, no tumor, different subgradings, all these other classification methods, but they all rely on the ranking parameters and the attention backbone. Yeah, and another really cool output of this work is using those attention scores. You can then, so the patches correspond to attention scores, so you can give lower ranked patches sort of like a cooler, like a blue tone, and then a higher ranked patch as a red tone, and overlay that in a heat map. So that's one way. That's the full pipeline of like our work right now and how it occurs. Yeah, that might be a bit too technical, but um, I guess another way of saying it is that we take a simpler method would be a simpler way of explaining it is we take the image, we segment the relevant tissue regions, and then these patches are then basically put into a bag, and this bag is then analyzed on the patches in this bag is given one label, right? So all these patches will correspond to, tumor or no tumor, and then you look at all these different bags of patches, and you find which ones correspond and have the higher ranking to the diagnosis label. So that's another way of thinking of it, of like thinking of these as like the patches as bags of information to be ranked.
Yeah, that's great. Thank you. I like your analogy of bags with stuff inside of them. But yeah, that's super interesting. It's something I did not know myself about. And then kind of talking about the research group that you're currently part of, the AI for Pathology Image Analysis group. So how did you come to join that group at Harvard? And has there been any favorite projects so far or stuff that you're really excited about working on?
Okay, cool. So I guess I guess it kind of starts at like I told you about my computational biology background in undergrad, but then when I graduated, I actually worked as a software engineer for a year at Google, and in that time, I worked on some machine learning teams. And that kind of like spurred my interest in machine learning and applying it to other problems. So when I came to Harvard for my PhD, I was really interested in like either doing machine learning or some other kind of similar work to on biomedical problems. So I rotated in many different labs. I actually did 5 rotations, if you can believe it, in my first year. Yeah, I picked places that had interesting biomedical problems and deep technological methods that they were using. Like I rotated in one computational immunology lab that was doing developing RNA-seq analysis methods. I worked in a RNA genomics lab that does like sequence analysis and develops methods for that. I worked in a group that does sort of does like systems pharmacology. So I did another one in a protein in a protein prediction lab. So these are all the kinds of labs that I worked in, but I chose Faisal. He was my 4th rotation, and it was I in my first 2 rotations the mentors were kind of I met them once a week and we set a timeline, but I just couldn't just walk into their office and expect them to help me. I had to set a time to do that, and then people are busy. But with Faisal, I saw that I could walk into his office at any time or like knock on his office sometime during the day, and he would usually make time for me. Not many PIs will make time for you every day if you want it. I saw in his with his other students, he had another PhD student, and he sat there and he coded with him, and he actually helped him write and his paper for submission. He was doing all these things that other PIs wouldn't do, or maybe would delegate to postdocs. And I think it's also because he was a very new lab. He was there currently he's been at Harvard for about 2 years, but when I first met him it was less than a year. So just his closeness to students, the amount of mentorship he was giving was kind of first on my list, and what really drew me to want to join the lab. But yeah, secondarily, like, and it's doing really good research. I mean, we have multiple publications now in Nature. We are our work is funded by very big NIH grants. So it's a great lab to be in. It's a great work environment. It's great research. We do we work on really important, impactful medical research. So it was just kind of like the best of both worlds, I think, of being like the high mentorship small lab plus the high funding, high impact. And and another big thing that I thought was very cool is that I didn't actually finish my rotation project. I wanted to leave, and I was like, well, I wanted to finish it to prove to him that I could do the work. But I said, Faisal, I have my next rotation coming up in a week, but I didn't finish this project. Is it okay if I go? I think I want to join the lab, but do you think is there anything I could do to prove to you that I'm I'd be able to do this work and be worthy of joining the lab? And he said, Sharifa, you don't have to prove anything to me. I think you're very qualified. I think you'd make a great addition to the lab, and if you want to join, you can, and you don't have to stay more weeks and like finish your project. I already know you'd be a good fit. I already know that you could do that work. You have to figure out what you want to do, and if you want to go and do another rotation, that's fine with me, and you can always come back when you're ready. So that those kinds of words and that kind of freedom was really impactful on me. So
yeah, that's great. I think to have that kind of like outward support and mentorship from a PI is like really valuable. And I think, yeah, finding like a supportive lab culture, I feel like for a lot of freshmen, who want to just like jump into research and get started, it's actually like really important to consider the kind of like group that you'll be stepping into and whether or not there's support for you. So yeah, that's really great to hear. Yeah, so okay, transitioning away from graduate school for just a little bit. You mentioned that you were a software engineer at Google for a year before starting your current studies now at Harvard. So what was some of the work that you did in there? And then additionally, how did your experiences differ working in like industry at Google versus now studying for your PhD?
Okay. Um, so like, yeah, I could talk a little bit about the work I did there. I was in their new grad training program, so I did 2 months of sort of like intensive classes and project-based work where I would learn different Google technologies, and then I did 2 rotations in different departments. One was Google Maps machine learning, and the other one was search infrastructure. And so the Google Maps machine learning team was very interesting. They, I don't know if you've ever looked at go to Google Maps and look at your timeline, but there's a pretty accurate, description of your day if you have, location services on, like what mode of transport you took, where you went, what time. Um, and this data is all really useful to Google. And so the team really, what it does is it tries to make that timeline as accurate as possible. And that timeline is used in other departments for other services. But yeah, just basically figuring out what you're doing, where you're doing, how are you getting there, making it as good as possible. So yeah, I worked on the data pipeline for that, like modifying the historical model, different ways of validation methods. So it was pretty interesting. Um, and yeah, I mean, it's not, but it's interesting at the end of the day that that work is used for revenue. That work is not just being done for scientific advancement. It's really interesting technical work, but it's also done for for a product based purpose. Um, and then yeah, my next rotation was in the search infrastructure team, and which they basically handle the ranking algorithms and determining when you search what comes up in the first couple pages, and making sure that that's high quality information. So I worked on some of the backbone for that, and more so the data processing pipeline. But it was very interesting to see how large the infrastructure is, and how many people are working on this specific thing. um, the it was Yeah, it was, I mean, you think about it, like everyone uses Google search every day. I mean, well, most people do, they search something and it's usually on Google. So I think being a part of that and understanding how it works better was really just a really great learning experience. But yeah, the reason I left is, well, I actually had, in my senior year of college, I had applied both to Google and to PhD programs. I applied to jobs and PhD programs because I wasn't sure, what I wanted to do. Some people say a PhD is not, the best investment choice. You could go make a lot of money as a software engineer right out of college. You don't need a PhD to do that. To work in industry as that. So, and I never worked as a software engineer, or did a software engineering internship. So I said, I'll work for a year, and then I'll figure out if I miss biology, or if I want to do my PhD. And at the end of that year, I did miss it. I missed it a lot. I would find myself talking about random biology things with people around me. I would think of experiments. I would say, like, oh, maybe we could apply this to this thing, and they're like, but why? Like, it was I just kind of missed being in that sort of academic research environment and working on problems that may not be um, the most monetary, or like generating the most monetary value, but could provide more like deep scientific knowledge. So in that, I went back and I said, I'm ready to do my PhD now, and they said, yeah. So, and I started my PhD. So that's a and I'm really happy. I'm able to do the impactful work, and it's still really technically challenging, but I'm able to pursue my research interests and what I think is important without the thought of will this bring monetary value. I think.
Yeah, I have to say, even as like undergrad students, there's a lot of people studying computer science here at MIT. And I feel like everyone is kind of aware of that. Like, oh, if you come out of college with a computer science degree, you can, get a good position as a software engineer and stuff like that. But,
Mhm.
it's important to do work that you find is meaningful. So I appreciate what you said about that. Yeah. Okay, so you have also tutored in college and then taught computer science for several years as well. So, what is your favorite part about teaching and mentoring other people?
My favorite part about teaching. I mean, I want to say it's the part of, seeing that, seeing that something that they previously thought was impossible or incredibly difficult that they couldn't do is now, makes sense, and it's really attainable. And I think that really resonates with me as when I started college, and even before that and after that, I mean, I started college not having any computer science background, right? I declared my major, and in my intro class, I thought I was so dumb to start with, right? Like there was these guys with GitHub accounts who, were just coding it up, and I I thought, I was asking the most basic questions, and I just thought, is there something I'm not getting? Meanwhile, I realized that, not everyone starts at the same place. Some people have um, greater knowledge bases when they come into a class. They have different experiences, so your journey and the way you learn is different. Um, so I think, and for me, I've had a lot of tough moments through that journey, and I think helping other students to get over that, and um, to help them progress, I think is really really impactful, and means a lot to me. Um, so yeah.
Yeah, that's great. I can kind of relate with my own experiences in computer science classes so
Yeah.
far. Um, yeah.
and and to also talk about mentoring a little bit, I mean, I think there's a lot of things that people don't tell you about stuff, right? Like how to apply for research internships, or how to apply to jobs, how to do interviews, how to, I don't know, even how to like talk to professors and like say like, oh, can I get an extension? Oh, or this thing in lecture didn't really speak to me, like how to use office hours. Like I'm a first generation student, so these things were, no one told me these things. And a prep for their careers.
Yeah, sorry. I think I lost you a bit there, but I think you're generally saying that, as a first generation student, no one was really there to tell you, just even stuff like how to talk to professors.
Mm-hmm.
So,
So yeah, I made it my priority, to kind of teach that information and pass it along to underclassmen. And yeah, I'm still in contact with a lot of people that I that I mentored in college. A lot of them even still have me look over their resumes, or prep them for technical interviews. Um, but yeah, it's really rewarding, and I think there's a, I think some people may say, if other people succeed, that's less opportunity for me. But I think there's enough opportunity for everyone to, and helping the next person, will just make society better, and it also will improve you, I think.
yeah, I really like that sentiment that, there's enough for everyone. So, should helping everyone helps society as a whole. Yeah. Okay. All right. So at Harvard, you said you were part of the like systems synthetic and quantitative biology program. And you also serve on the DEI committee for that group. So could you just speak a bit about the importance of work in DEI to you?
Okay. Well, yeah, I mean, I'm a first generation student. Minority. You know, these things were really profound to me. Not necessarily growing up, because I was in a very diverse area of New York City, and I was exposed to many different places. But I think when I went to college in a small liberal arts school, really hit me. I was accepted through um, the Higher Education Opportunity Program, which is specific for diverse low income students. Um, and I had to I would go I the DEI efforts were just like kind of core to why I was there. And so I just made it my priority to give back and try and help other students get these kinds of opportunities that I did and make it less hard. um, I did a lot for lobbying for these programs at the Capitol, and at the New York State Capitol. Did that every year. um, I also and I think facilitating conversations and being able to change people's perception is a skill, and something that I wanted to work on more. So I joined like a diversity and dinner and diversity around dinner and discussion around diversity association at my school, and I sort of worked on a lot of these tough topics and like how to talk about them. I think that gave me a strong foundation for now the work I do here at Harvard on the systems the DEI systems biology committee, um, where we were trying to plan you know to make the school more inclusive, to make it a better environment. I think DEI, having more diverse people, having more diverse opinions, makes science better. You have to see things from all different perspectives, and I think science is better when you have a diverse group of people working on it. um, so I think diversity is great for the school. It's great for society as a whole. And the work I'm doing right now is, I mean, we've had some small wins so far. We got so DEI work is usually seen as like sometimes even a distraction to research or other academic work, like seen as like extracurricular. So we've started trying to highlight the work of students and professors by handing out DEI awards to people who are doing this kind of work and recognizing them formally in the department. I think that was a good first step. We're also working towards having a DEI service commitment. We're hoping to have that done with having service work be a part of the your development plan, but DEI being one of the things that you could do. When we yeah, and we also we're not currently students are not currently allowed to review applications or we're not allowed to do that at Harvard, but we were able to host a DEI info session and learning workshop for prospective students. So I think showing them that we value this work and that they would be valued here, and was a really good thing. So yeah, that's kind of like what some of the things that I've been working on and we've been working on as a group.
Yeah, especially want to echo the importance of DEI in science. There's a lot of like academic institutions and higher institutions that are like, I guess, carry a lot of weight in the scientific community, but if those places are not diverse and not equitable or inclusive, then there is an issue there. Okay,
Yeah.
all right.
Yeah, the ivory tower is a
Mm,
difficult place to be, I think, and it can be lonely. So it's important to have that diversity to kind of break down those walls.
yeah, for sure. Okay, going back to research for a little bit. So this is kind of a broader question, a little bit more abstract. But basically, what do you see as a role for like deep learning, artificial intelligence, machine learning in the realm of medicine and treatment? So what do you think is in the future of this field?
Okay. I think first off, I do not think we are going to replace doctors at all. I think a lot of people in the medical community, have their notion that, oh, AI will become so good and our jobs will be at jeopardy. I think that's not the case. Specifically, I'm working on projects that, like I said, like they create heat maps, they create visual aid and other supplementary tools for clinicians. It's not creating the end diagnosis. It's creating a supplement to the tools at the clinician's disposal. And I think that is the role of AI, is to streamline the process. Highlight tumor regions, highlight regions of interest, to clinicians, to shorten the pipeline and the time that they take to analyze these things. I think it's also would be really cool from a research perspective to be able to look at all this data. Like, we have access to thousands of cases and thousands of slides at the Brigham Pathology. And so we are able to do deep learning on so much data. It's impossible for one person to kind of look through all of this data and create, standardized conclusions. We can aggregate all of this and run models and create, you know, I think, pretty what's the word? Like, well, I think what we're really trying to do is create a greater like biological understanding. So we're able to have all of this information and just synthesize it to be more palatable to clinicians and to increase clinical understanding of these things. I think, for example, say, like, I think a lot of clinicians, like, they have like an intuitive sense of like why something is something. Like, why, when I look at this slide, why is this slide cancer? Why is this, I don't know, why is this patient rejecting this organ, from just sort of a, like, from all their years of research. I think, of all their years of working on this medical problem, um, I think AI can help streamline that process, but also create like standardized medical information and things to look at, and that could be used also as an educational tool for training clinicians and for providing more information and understanding to the community. Those are the main ways I see, as an education tool, a way to aggregate data, and sort of as a supplementary diagnostic tool to clinicians. I don't expect it to replace doctors. A robot AI will not be, seeing you at your next appointment. It'll be a human doctor.
Yeah, I feel like a lot of those sentiments about like, oh, AI is gonna like replace this in this job is just a lot of like hysteria and not definitely not true. But yeah. All right, so okay, I think this is a bit more of a fun question. I'm also not sure if you can hear the wind outside, but
A little bit, but it's okay.
a little bit. Okay, it's all right, it's fine. Okay, so if you could go back in time and tell 18-year-old Sharifa anything about college, about PhD work, whichever you want, what would you tell her?
I mean, I think, trust in yourself and that everything will work out. I mean, stick to your instincts. I think what I did and what I worked for came out really well, and especially this week with my passing of qualifying exams and my getting of my NSF research fellowship, like a lot of the things that I've been working towards have, been manifesting, have been coming to fruition. I think that, in college, that was also the case too for a lot of things. The more I worked really hard at a lot of things, and I was able to reap those fruits, from, my job offer and my PhD offer. Yeah, I think 18-year-old Sharifa is fine. I think she definitely worries too much. I think she has, her 5-10 year game plan, which is, is constantly changing, but she's always looking toward the future. But yeah, I would just, tell her to trust in herself, keep following her instincts, and things will be okay. Like, don't stress too much about it. And also don't, I know especially in the first 2 years, I think I was very heavy on imposter syndrome. It took it took a lot for me to get over that, I think, and I still have a little bit of it, but I think once I got enough experience under my belt and understood that I was good at what I did, and um, other people valued my work and I valued myself, and my worth is not tied to my productivity. I think those are all things I learned along the way. But I think if I told that to her now, she probably would still be worried. So I don't know. I think these things you just have to figure out in the moment.
Yeah, definitely true. It can, I feel like you might have a vague sense that in the long run, in the future, everything will probably turn out just fine. But in the moment, it can still feel very stressful and unsure.
Yeah, definitely.
Yeah, okay. And then I think this is our final question for today. Um, okay, for younger students interested in pursuing machine learning or computer science in college, do you have any advice for them?
Mm, I think you can gain a lot of knowledge not only by taking, coursework, but by working on interesting problems that, deep learning can be applied to. I think once you have that sort of foundational knowledge of machine learning and some deep learning, go out there and, look at problems that you would want to solve and think about how machine learning and deep learning could help solve these problems. And I think that'll also help you to research machine learning and AI better, um, to increase your technical knowledge as you work on this project, as you learn more about it. And I think that would be the most useful. Not, I mean, you could take 20 courses, but if create some sort of like AI climate model and that creates useful predictions, I think that kind of on the ground training is would be really impactful, and would show people that you not only have foundational skills, but you have the ability to apply it.
Yeah, truly like learning by doing and figuring out what you can.
Mm-hmm.
Yeah,
Yeah.
exactly. All right, so I think that's gonna conclude our interview for today. Thank you so much for your time. This was a really fun experience for me, and I hope it's
Mm-hmm.
fun for everyone out here watching this interview as well. Do you have any like final closing remarks or just any last things you would like to say?
No, but thank you for having me. And if you're ever, I mean, if anyone out there wants advice or information on, how to apply to PhD programs, how to do research, what, my thoughts on, science and other things are, just let me know. I'm really, I'm happy to help.